Hello learners, welcome to lesson 3 of Introduction to Machine Learning. For this lesson, we are going to learn the evaluation metrics for classification and regression models. We are going to learn about confusion matrix and some terms used in confusion matrix, also some concepts around confusion matrix and performance evaluation metrics of classification and regression models. So, there are very many different metrics for evaluating the performance of classification models, and they include the accuracy, sensitivity, precision, F1 score, area under receiving operating characteristic score, that is AUC. And most of these metrics, they can be calculated from confusion matrix. So what is confusion matrix? This is the diagram for confusion matrix. We have the positive value here, the positively predicted value and the negatively predicted value here. And we also have, and we call the positively predicted value as true positive, while a positive is a value that is actually negative but was wrongly predicted as positive. While for false negative, we have a class that is actually negative but wrongly predicted for positive. So what is confusion matrix? A confusion matrix is one of the metrics that evaluate the performance of a classifier on a test data. It is a table that allows visualization of the performance of an algorithm. It is actually a table that allows visualization of the performance of an algorithm on different classes. Now, a true positive class is a class that is actually positive and rightly predicted as positive, while false positive is a class that is actually negative but wrongly classified as positive, while false negative is a class that is actually positive but wrongly classified as negative, while true negative is a class that is actually negative but is rightly classified as a negative class. So the rows of the confusion matrix, these are the rows, they present the actual labels that were contained in the data set, while the column presents the classifier predicted vice versa. But the diagonal actually predicted the true positive and true negative of the classes for the data set. So what are the terms used for confusion matrix? The following terms are commonly used, and we will use a diabetic data set as our case study. One, positive, that means that there is presence of diabetes, but if it is negative, then there is absence of diabetes, and we denote that as 0. So what is true positive? That a patient is actually diabetic and classified as being diabetic. So a false positive class, that means a patient that is not diabetic and the classifier predicted is a diabetic. So we refer to this as a type 1 error. For true negative class, that means the patient is not diabetic but the classifier predicted it as not diabetic. So this is a right classification. While false negative means that the patient is diabetic and the classifier predicted it as non-diabetic. This is a wrong classification or misclassification. So a typical example of a confusion matrix using logistic regression on diabetes dataset is what I'm about to show you. Now, for this diabetic dataset, we have 41 people that are diabetic, and for non-diabetic, we have 72 patients. So out of the 41 patients that are diabetic, 38 of them were rightly classified as diabetic. Truly, this is a good classification, a right classification. While 3 of the patients, they are actually diabetic, but they were wrongly classified or misclassified as not diabetic. While for non-diabetic patients, we have 72 patients that are non-diabetic. So 70 of them were rightly classified as non-diabetic, while 2 of the patients were wrongly classified as being diabetic. So performance evaluation of a classification model. So these are some of the measures, statistical measures that we use to measure the performance of a binary classifier. Evaluation metrics like accuracy, sensitivity, and specificity. So classification or classification rate or accuracy of any given classifier is the ratio of what classifier predicted correctly over the total number of predictions. So what about the evaluation metrics for regression model? We have rightly defined in our earlier classes that unlike for classification model, classification has label and they are categorical variables. So but the output of a regression model is continuous. They are numeric value. Therefore, we will have different evaluation metrics to assess the performances of such model. So the performance model, the performance metrics that we come into contact with frequently are one, mean square error, the root mean square error, the mean absolute error, but the mean absolute error. So now, the lower the error value, the better the model. So all these metrics that we had mentioned, the mean square error, the root mean square error, and the mean absolute error, their value range from 0 to infinity. So summarily, in this lesson, we have learnt the evaluation metrics for classification and regression model. We have also learnt about the confusion matrix, the terms used and the concepts in confusion matrix. We have also learnt the performance evaluation of a classification regression model. So in the next video, you will learn how to perform a classification or a regression task using the Jupyter notebook. I hope you have enjoyed this video. See you in the next lesson. Bye.